All right, let's dive into one of the most intuitive and powerful models in all of machine learning, the decision tree. Now, these are the building blocks for some of the most advanced AIs out there, but here's the best part. You already know exactly how they work, even if you don't know you know it yet. So picture this. You're heading out the door and you have to make a quick choice. Do you grab an umbrella? That simple split-second mental flowchart that you run through in your head, that is the exact logic behind how these incredibly sophisticated algorithms operate. So let's actually break down that decision. Because in doing that, we're going to uncover the three essential parts that every single machine learning decision tree is built from. The first thing your brain does, almost automatically, is ask a question. And it's probably the most important one, right? Is it actually raining right now? This is the starting line for our entire process. In the world of machine learning, that first big question has a name. It's called the root node. Think of it as the trunk of the tree. It's the very first split that gets the whole thing started. Every tree has to begin somewhere. And boom, just like that, the answer to that one question, yes or no, immediately creates two different realities, two totally separate paths you can follow. Your decision has just branched out. And yep, that's literally what they're called, branches. Each branch represents a different outcome from your question, and it leads you one step closer to your final answer. Eventually, after you follow a path, you get to the end. There are no more questions to ask. You've reached a final conclusion. You either take the umbrella or you leave it at home. And those final outcomes? We call them leaf nodes. Makes perfect sense, right? They're at the very end of a branch. A leaf node is the final prediction, the answer the algorithm has landed on. Once you're there, the journey's over. Okay, so that all makes sense for a person, but how does a computer learn how to ask the right questions and in the right order? I mean, how does it build this tree all by itself? Well, this is where the real secret sauce is.
And this really gets to the heart of why they're so popular. You know how a lot of AI models are called black boxes because you can't see how they work? Decision trees are the exact opposite. Their whole goal is to build a flowchart that makes perfect sense to us because it thinks the way we do.
So here's the most critical piece of the puzzle. When a tree is trying to decide which question it should ask next, it has one single goal: to create splits that are as pure as possible. It wants to ask a question that sorts the data into the neatest, most organized groups it can. This illustrates it perfectly. Look at that impure node on the left. It's just a mess, right? A total mix of outcomes. It's uncertain. But a pure node? That's clean. That's certain. Everyone in that group made the same choice. The algorithm absolutely loves that kind of certainty. And it measures this using a really clever idea called information gain. Think of it like this. The algorithm looks at all the possible questions it could ask, like, is it cloudy, or is the forecast over 50%? And then it calculates which of those questions will do the absolute best job of sorting that messy, impure data into clean, pure groups. The question that reduces the most confusion, the one with the highest information gain, wins, and that becomes the next node in our tree. But this obsession with purity, with getting everything perfectly sorted, can lead to a really big problem. A tree can get so good at its job that it starts to memorize the noise instead of the signal, and this leads it straight into the overfitting trap. It's kind of like this. An overfit tree is the student who just memorized every single answer on the practice exam. The moment they see a new question they've never seen before, they completely freeze. They can't generalize. On the other hand, an underfit tree is like the student who didn't study at all. It's just too simple to be useful.
So our goal is to solve this Goldilocks problem. We need a tree that isn't too complex, isn't too simple. It needs to be just right. One that finds the real pattern in the data without getting sidetracked by all the random noise.
And we do that with a technique called, fittingly enough, pruning. Pre-pruning is when you set the rules beforehand. You tell the tree, hey, don't grow any deeper than this. But post-pruning is often more effective. You let the tree grow totally wild first, and then you go back in and strategically snip off the branches that are just adding complexity without providing any real value. So we know how a tree learns and how we keep it from getting too smart for its own good. Now let's look at where these models are being used to make some of the most important decisions out there. You see, trees basically come in two main flavors. You've got classification trees that predict a category. They answer what kind questions, like, is this email spam or not spam? And then you've got regression trees, which predict a number. They answer how much questions, like, what's the price of this house? The core logic is identical. They just use different kinds of math to decide what a good split looks like.
And their use in the real world is, wow, it's staggering. We're talking about banks using them for loan approvals, doctors using them to help diagnose diseases, and retailers using them to predict which customers are about to leave. These are not small things. This simple branching logic is making critical decisions every single day.
But here's what might be the most critical takeaway. If you understand how this one single tree works, you've unlocked the secret behind the giants of the industry. Models like random forest and gradient boosting, the ones that win competitions, are really just big, clever teams of individual decision trees all working together.
So, after all that, what's the one thing that you should really walk away with? What is it that makes the humble decision tree so incredibly powerful and long-lasting?
At the end of the day, it all comes down to this. Their real superpower isn't just their accuracy, it's their transparency. A decision tree is explainable. You can literally trace the path it took and understand the exact logic it used to arrive at a conclusion. And in fields like medicine or finance, explaining why isn't just a nice-to-have, it's a requirement.
And that transparency, that ability to see the logic, leaves us with one last massive question. When a tree approves one loan but denies another, or when it recommends one treatment over a different one, if its logic leads to a mistake, even a catastrophic one, who then is ultimately responsible for the choice it made?